All right, guys, let's take a look at your notes on the 6 simple machines. These are your 6 simple machines right here. The lever, wheel and axle, pulley, inclined plane, wedge, and screw. Okay, and I'm just going to skip down here because the main notes on this one are talking about the wheel and axle and the screw. So this is your wheel and axle, and one thing I want to look at here for calculating the ideal mechanical advantage. This is comparing the distances, and if one thing you have to think about here is we're going to compare the circumference of our effort to our circumference of our resistance, because when you have a circle like this, and you can take a look at the wheel as I'm doing this, if the wheel turns one full turn from there to there, that would mean the axle, which is this part in the middle, is also going to turn one full turn. Okay, so we're comparing that distance. When the wheel turns one full turn, how far does the axle turn? And it's called the circumference of the circle, because these are two circles. The large circle is the wheel and the small circle is the axle. So our effort distance, if we're turning on the wheel part, this part right here, okay, if we're turning on the wheel part, then that's going to be our effort, and then the axle is going to be the resistance. So that's what we're looking at here. And for this one, for this example, we have an effort distance is right here. Okay, up in the right hand corner, you can see that's this distance from here to here. Okay, that is our effort distance. Okay, it's the radius of the wheel, and then we have the axle. Okay, I'm going to change the color here. So the axle is the distance from here to here. Okay, that distance, and we're told that that's 6 inches. So on the bottom here, we're going to take a look at it, and you could actually make the axle your effort and the wheel the resistance, but I'm just going to go at it as a more common way of looking at it, and that's this one down here. Okay, this one right down here. Okay, on the bottom, and this is our distance. Our effort distance is 20, and that's the radius of the wheel, and this is the radius of the axle. Okay, so it's 20 divided by 6. And you say, well, I thought it was the circumference. Well, it is the circumference, and we're comparing the circumference of the wheel to the circumference of the axle. So here's our equation for that. Our effort distance is the circumference. 2 times pi times the radius is the circumference of the circle, or we could say pi times diameter. So if we're using that equation right here, okay, on the bottom here, we're looking at IMA equals pi times the effort diameter divided by pi times the resistance diameter. Well, pi cancels out, as you can see right here. So all we're left with is our effort diameter divided by your resistance diameter. Or we could say our effort radius times our distance, or excuse me, our resistance radius, because it's going to give you the same answer. In this case here, we are given the radius is 20 for our effort, and our radius for our resistance is 6. So it's going to be 20 divided by 6 is 3.33. If we change this is the radius compared to the radius. If we changed it to the diameter compared to the diameter, the radius of our wheel, again, the radius of our wheel, we're talking about, let's back this up here. We're talking about this right here. Okay. This is the radius of the wheel. I'm making a mark on the wheel if you haven't noticed. From here to here, this distance is the radius of the wheel, and then the small one's the radius of the axle. So we've got 20 compared to 6, but if we doubled that to get the diameter, we would have 40 compared to 12. Okay, 40 to 12. Well, 40 to 12 is going to give you the same answer, 3.33. So that's our answer for that one. And then we have the wheel and axle AMA. The AMA is comparing forces, the force of the resistance divided by the force of the effort. And here we have the force of our effort, and here we have the force of our resistance. So resistance divided by effort. So we get 200 divided by 70 would give us 2.86. And I'm looking right down here if you haven't figured that out yet. Okay, so 2.86, and then we have that math right there to give you 2.86 for our AMA. We divide 2.86 by our answer we got for our IMA. So we've got 2.86 divided by 3.33 equals 0.859, and that is equal to 85.9%. That would be the efficiency of that wheel and axle. Now we have the, let's back that up. Now we have the example of a screw. A screw is also kind of a unique machine. It's like an inclined plane wrapped around a cylinder. So if you take your pencil and you get a piece of paper and you cut a triangle shape out of the piece of paper, you could wrap that piece of paper around the pencil and it would actually look like a screw. You can see in the picture here that that's what they're doing. They're making this to look like this over here, which is a real screw. So you're changing rotary motion, which is circular motion, into linear motion, which is straight line motion. So you're going to turn the screw, and the screw is going to go straight into the wood. Okay. So the important pieces of information for this is here we've got this is typical information for a screw where you're given the diameter, you're given the threads per inch, and then this is just a description of the kind of thread. It is either coarse or fine thread. But the real important piece of information that we have for this is right here in the middle. Okay, 13 threads per inch. So this right here on the right, this is the pitch. Okay, the pitch is the distance between two threads. So how far will a screw with 13 threads per inch move if you turn it one full turn? It's 1 divided by 13 because there's 13 threads per inch. Okay, so when we do these problems, we're going to be using this number here, threads per inch. Sometimes it's abbreviated as TPI. TPI. Okay, you're going to need to know that because sometimes that's what you'll see. When you're calculating the IMA, we're comparing the circumference, again, the circumference of our effort compared to in this case, the pitch. When you turn this wrench one full turn, the screw will move the distance of the pitch. So we need to know the circumference of the circle that's made when we turn this wrench. And in order to know the circumference, I'm going to show you one. I'm going to move this forward here. When you turn this wrench, and let's see, this wrench right here, I'm highlighting it in yellow. Okay, the length of this wrench from here to here. Okay, you can't really see it on the screw, but it is on the screw. That becomes the radius of the circle, because when you turn the wrench, now you're not going to be able to see it turn, but it turns in a circumference of the circle like that right there. It is the radius. This distance is the radius of the circle. So the circumference of the circle is 2 times pi times radius. So this 8 inches for this right here, this 8 inches becomes the radius of the circle because it is the length of the wrench. Okay, so if I want to know what the AMA, I'm going to let's back up and do the IMA first. To calculate the IMA, we go 2 times pi times the radius. Okay, this number right here, we just said it's an 8-inch long wrench. That will give us the circumference of the circle, and then we divide that by the pitch. Circumference divided by pitch. So the pitch is 1 divided by 20. And again, I'll back this up again and show you that the pitch is this right here. Okay, the pitch is the distance. I'm on the screw right now, in the upper right hand corner, the distance between two threads. All right, it's very important. That's the pitch. So if we turn the screw 1 full turn with the wrench, if the screw will go in or out, up or down, depending the distance of the pitch. That's easy for me to say, huh? So that's why we're doing the pitch right here. Right here. So in this case, the pitch is 20. Okay? Oh, threads per inch is 20. The pitch is 1 divided by 20. Okay? So, do this multiplication. 2 times pi. 2 times pi times 8. And divided by 1 divided by 20. And that gives you this number right here. 1.005.31. That is your answer for the IMA. The AMA is your force of your resistance divided by your force of your effort. These are just numbers that you would read off of a scale. In this case, the resistance is 120 pounds, and on a scale, we'd read it as 35 pounds. So we'd go 1,200 divided by 35 gives you 34.29. The efficiency of this screw is dividing the AMA by the IMA. These are the numbers that we just calculated on the previous 2 slides. So the AMA is 34.29. The IMA was 1,005.3. We do that, we get a number of 0.0341. Multiply that by 100 to turn it into a percent, and we get 3.4%. Why is the efficiency so low? We have a question here on the bottom. Well, the efficiency is so low because we have a tremendous amount of friction that's in a screw. Okay, you're putting a screw through a piece of metal or through a piece of wood, and it's very tight, the threads onto the wood or onto the metal, and that's why you get such a low efficiency. Okay, hope that helps you guys out.